Okay, so welcome everyone for the CCSP session. My name is Rajiv Kumar, and I'm having 14 plus year of experience in this particular industry, specifically in the cloud security and the information security there. Over the time, I had acquired a good amount of certification as well there. You can say that I'm certified in information system security professional there. Apart from that, I'm also certified in information security management and C-risk, where we like in this particular course also we are going to discuss some of the concepts related to the C-risk here, which is going to very helpful while calculating the risk and defining the control and so on and so forth there. The main thing is actually I'm also certified in AWS and Azure there, specifically their AZ500 platform, which has been made actually for the security there, and AWS security speciality there, which is again from the AWS side there. So to understand the concept better, might be I will be going to utilize some of the concepts which we are normally implementing in the real world scenario there, so we can understand the concept better, and definitely it's going to helpful to pass the examination, and definitely one of the key thing is actually to gain the knowledge as well there. So let's begin. Now for this certification course, CCSP, there are some requirement we have there. So let's discuss some of them first. Okay, so this certification course is actually from IC Square there, is having some of the basic requirement there, which we need to understood there. The first thing is this certification is having total of 6 different domain, or you can say 6 different area to cover it up there, which is actually from the different stuffs which we need to understand about the cloud part there. And definitely based on that, we will be checking out some of the issues, and then some of the control, which is going to help me to implement the security properly within the cloud there. Remember, this is a management-based certification, so we are actually looking for some of the best practices which will help me to implement the control there. Like there are very many different guidelines available there, which is going to help you to implement the solutions properly there. Specifically in CCSP syllabus, we have NIST guidelines, which is predominantly available there for implementation of the control there. So we will be checking some of the numbers there, although you don't need to move into that documentation. But yeah, definitely, if you are trying to understand more about the security stuffs of any of the component, it will be good if you can actually revisit some of the documentations which I'm going to discuss here, like NIST risk management framework, risk assessment frameworks, then after the control implementation guideline, classification guidelines. So these are some of the important, you can say documentation, which is going to help you to understand the overall concepts of the security. And definitely then based off that, you can implement the security properly there. There are very many compliance programs we also have here, which is going to help you to implement the best practices, specifically in the cloud environment there. Remember, the main focus of this whole documentation is actually from the public cloud provider side there. So we are also going to discuss some of the stuffs which is actually we are looking to implement it there onto the public cloud there. But let's just start with the information about the different domain there. So as I told that we are having 6 different domain to cover up here, and this 6 domain is having you can say 6 different area, which is actually being the very integral part of the cloud security there. First, we must have a proper information about the basics cloud component there. So you can say the first chapter, or you can say the first domain, is discussing about the cloud architectural concept and design there. So in this first section, we will be discussing about the architectural concepts and design itself there. And the domain weightage for the examination we have right now currently for this first chapter is 17% there. So you can expect 17% of the question from the same domain there. And this domain is actually going to let you understand what are the different aspects of the cloud is. Like there are very many different definition has been actually given there by the different standardization bodies there. But predominantly NIST one is one of the popular one there, which is widely recognized and accepted by most of the industries there. So we will be checking about the definitions of the NIST specifically, and apart from that ISO as well. Then we will be checking out the 543 rule of the cloud, which is all about the 5 different attributes of the cloud there, then 4 deployment model and the 3 service model there. And around that, our discussion is going to be there, like some of the benefits of the each of the deployment model, some of the demerits we have for those particular deployment model. Then after we will be discussing about the service model there, and definitely based on that, we will be again having our discussion on the benefits and the demerits there. Now, this is going to help me to understand the risk related to them, and around that we are going to design the control as well there. So this is the first thing. Apart from that, we are having some architectural components as well there, and to design a proper architecture we also must have a proper information about the governance component. Apart from that, we will be also checking the overall enterprise risk management framework there, and the implementation tier after that as well there. So this is what going to be the main focus of this particular first chapter. Apart from that, some of the compliance program also has been discussed there in the first chapter, because again cloud is very much wide there, because most of the consumers around the world is going to dependent on that. So you can say that we have to implement the very many different compliance programs as well there, which is going to let me work onto the cloud there as a consumer. So definitely I will be looking for different standards, different regulatory organization, different regulatory standards also to be implemented there, industrial standards to be implemented there. And it is not only the provider who is having responsibility for that, even the consumer who is building the logical infrastructure of the cloud also have to make sure that their infrastructure is compliant with the given standard there. So the same we will be discussing about here. So let's see it is exactly what we have there onto the cloud concept there. But before, let me just introduce some other models as well. So as I told, the cloud architectural concept is having the 17% of the weightage there. The second domain, which is on the cloud data. Now, it's very much important that we should understand the different down there. So the cloud data security steps there, that is the second domain we have here to discuss. And the domain weightage is right now 19%. See, there are some changes happened there last year only, and after that the weightage has changed. Like previous weightage for this cloud data security was 20%, now it is reduced to 19%. And the overall information what we are discussing in this chapter, or you can say in this domain, is to understand the different type of storage, then different set of control for each of the storage given there. Like object storage and volume storage is one of the predominant storage options we have onto the cloud there. So for them, what are the controls given there? But again, object storage and volume storage is basically and primarily for the infrastructure as a service there. But what about for the PaaS and SaaS there? So we will be discussing all the same thing there, and then different set of control like the DLP, encryption, then after the SIM solution and other IRM protection. So these all things has been discussed under the cloud data security there. So we'll see there how exactly those controls are going to help me to secure my data. And again, data is one of the most crucial part of the component, which is very much attached to the goal of the organization. So anything which is having proper value, we have to actually protect it there. So what are the control and what are the best practices we're implementing? That is again going to have our discussion in this domain number 2 there. In 3, we will be discussing about 2 of the service model. One is the infrastructure, and the another one is going to be the platform as a service there. So infra and PaaS service security, we will be discussing in the domain number 3 there. So different components are there for the infra and the PaaS. The main component I must say there, that it is the compute and the storage along with the network. So for them, what are the controls, what are the risks, and how do we implement the best practices? Again, that is going to be a discussion point along with the business continuity and the disaster recovery, components there. So we have some authentication related components also needs to be discussed in the same domain there. So we'll check it out there. Again, the weightage for this domain is 17%. Fourth domain we have related to application security. So for the application part, first thing we will be discussing about the design section of the application, and then after we will be checking it out the different type of risk which is available around the application security there. And there's some new approach which is being added while developing the application for the organization. So what should be the best practices in the framework available there that is going to help me to design the application properly? That is again going to discussion point of the fourth domain, and the relative weightage is again the 17% there. Fifth domain is on operations. I must say cloud security operations there. So within the operations part, we will be discussing about the internal and external operations there, where the cloud consumer and provider both are actually responsible for maintaining the steps within the cloud there, which actually require both logical and physical operations activity there. When I'm saying logical, there are some administrative controls we have to implement, like we have to have a proper particular process there, and that process needs to be understood and followed there, like change management, incident management, risk management. So these are some of them. Apart from that, some of the benchmarks available there from the CIS and other stuffs there. The relative weightage for this domain is also going to be 17% only in the examination there. So we'll be preparing around the same there. And finally, the last domain, which is the sixth one, which is on the cloud security compliance and standards there. So laws, regulations, standards, these are what exactly we will be discussing in the last domain, which is on the legal and compliance there. So the legal and compliance chapter, where we will be discussing about the different type of legal components which is may impact your cloud security while you're implementing, that one is discussed there. So we'll see that particular part in the last domain, and relative weightage is 13%. So that is how exactly the whole chapters have been arranged in the CCSP syllabus. Okay, so yep. So these are the different six domains we have, which we are discussing, and definitely our first discussion point is going to be from the first chapter, which is cloud architectural concept and design section. There again, most of my time I'm going to spend on the whiteboard, or might be onto the console of the different providers there. So let me just open at the same time the provider console there. So definitely, whenever I'm going to discuss some of the point, might be for the better understanding, I will be taking the examples from the providers directly there. So quickly, let me jump to my both of the portals and the console of from the AWS side there. So this is what the AWS console is. So now remember, we are actually discussing most of the services which is actually approached by the public cloud providers there. Definitely, private cloud is also one of the important stuffs we have, which we can actually utilize there. But mostly the security issues and the privacy issues, and I must say the compliance issues there is actually from the public cloud provider side there. And this is the reason that one is going to be the biggest factor here to discuss and to understand the different kind of implementation tiers which is available there. So in front of you, this is the Azure dashboard. So Azure is one of the public cloud provider, which is from the Microsoft, and it is right now in second in position there after AWS there. So according to Gartner's report, AWS right now on top, definitely because of their open integration features and some of the security stuffs, which is right now best for them. It is actually on top. But even Azure is also coming very fastly in the market there. I can say they have taken lots of shares in the market as well there. Definitely Azure might be in the future is also going to be in a top there. If in terms of availability, I'm talking about, in terms of number of data centers, I'm talking about, Azure is actually, it's way forward there. So definitely both of the providers are actually competing with each other for each kind of services there. If you're going to work under the AWS console, and when you're working on the AZ console there, definitely you will feel that AZ console is much more smoother and faster and well organized. And this is, Microsoft has been known to their user friendliness stuffs there, and that is what you will be facing, and you'll be getting into the Azure side as well there. So in terms of usability, I can say definitely Azure is much more smoother as compared with AWS. But in terms of security, I'm talking about, AWS is it's actually far better till now there. But as I told, that Azure is also coming very fastly in that particular side. Specifically, their IAM tool is much more enhanced there. So we'll see both of the steps one by one for the better understanding there. Okay. So before I move on, so first thing, this certification we already know that is actually from ISA Square, International Information System Security Certification Consortium. This is one of the not-for-profit organization. Their mission is actually to promote the use of best practices for providing security assurance. And remember, ISA Square mission is not only in the cloud computing; they are actually in the different area. Like I must say, the information security is actually one of the core area for that ISA Square as well there. But definitely they are also having stuffs in the another part, like in the software development, might be into the assurance programs. In the cloud, definitely we have, and you are seeing in front of that same thing there. So this credential is right now one of the highly recognized credential there, CCSP I'm talking about. Now this credential is going to let you know there what are the different stuffs we actually have there within the cloud there, and how exactly it will work there for us there. Now I must say that this is one of the highest level of security certification till now available into the market, specifically which is vendor neutral certification there. So we have some vendor specific security certification for each of the vendor. Like when you're going for the Google, we have the Google security stuff. When we go to the AWS, in AWS also there's some security tools given there which you must understand as a security engineer there, specifically on the cloud. And definitely for the same thing is also for the AWS there. Now the main goal and the main agenda is to understand the tools available onto the provider side so you can protect your organization. And that is what the main focus area of the vendor specific certification there. But this vendor neutral certification is not having a specific idea over the tools there. Definitely we will be discussing about the tool just to understand the implementation of stuffs there, but it is not focusing on any of the provider tool which we need to utilize there. But over and all, most of the tool names are actually same. The implementation stuffs and their, each of the vendor is actually calling that particular tool with a different name there. Like you might be utilizing Cloud Shield for the DDoS protection in the AWS, and in case of Azure, it is called as the DDoS protection plan there. So very much similar to that. See, the DDoS protection is actually required for each of the organization. It's not like for us, it is very much newer there. But the thing is, each of the provider is having their own way of tackling that solution. And definitely each of the provider has given their own tool to manage it properly. So we need to understand the name sometime is specifically you're utilizing that particular stuffs into the cloud there. But over and all goal of the CCSP is to understand how exactly the DDoS is working. What is DDoS first there? Then how exactly DDoS work is working, and which tools are available onto the cloud, which is going to help me there to sort out the issues there. Okay, there are two steps we have in the CCSP. First, you need to pass the examination, and the second thing you have to, prove that you have the necessary experience as well. So as we discussed that we are having total of 6 domains. So when you appear in the examination, first thing definitely you need to register yourself in the Pearson VUE Examination Center for the CCSP. And right now the examination cost is $599 there. So this is what the examination cost, and definitely it is actually where exactly you're located. Based on that, if there is any taxes there, so even that one too is going to be added on top of the 599 there. So total number of question you will be getting in the examination is 125. Out of 25 questions are just experimental. It means it's just for the future purpose. SC Square is always integrating some new question there just to check their effectiveness and overall stuffs, how exactly the users are responding for that one there. One of the best part with the ISIS squad is that with the support team and with the members actually, they are trying to get some new stuffs there, which is normally from the real world scenario, and they're trying to integrate in the examination there. So those 25 questions are going to be just experimental there. You will be not getting any marks, and definitely there is no negative marks as well there for that one. But yes, you have to what exactly those 25 questions are also, it is not revealed there. It means it could be the mix of within that examination only there. It means you will be getting marks only for 100, not for 125 there. And you need to secure 70% to pass the examination there. So once you secure there, the examination can be closed and you can actually go home after this one. So 70% is the passing grade we have there. But after passing the examination, it doesn't mean that you will be awarded with CCSP certification there. So after passing the examination, the next step is actually to, you know, endorse your overall experience there. Remember, for this certification, you must have the 5 year of experience out of 3 year minimum should be in information security and 1 year minimum in any one of the domain which we had discussed. So we have 6 domain. And so in any one of the domain, you have at least 1 year of experience. That one is required, and 3 year minimum experience required in the information security. So I must say 3 plus 1, which is going to be total of 4 there. But we require total of 5 year of experience there, remember. So these are the minimum. It means to prove overall experience, like might be you're going for 4 year of experience in the information security and 1 year in the cloud, or might be 3 year in the information security and 2 year in the cloud there. But suppose you wanted to get this 1 year of wave off, which is not mentioned here. So for one, to get this 1 year of wave off, either you can achieve the CCSK certification, which is one of the cloud security certification only there, but from the Cloud Security Alliance. So after getting the Cloud Security Alliance CCSK certification, you will be getting the 1 year of wave off there. Apart from that, if you have some computer related degrees there, okay, that one too is going to help you provide the 1 year of wave off there. But the minimum experience you must have this 3 year in the information security and 1 year in the cloud. And I'm not saying that specifically in the cloud, even if you have the experience in the security operations there, that one too is going to work there. And to prove the experience, you have to first and initially provide your necessary information in your CV, and you need to upload it into the ISA Square portal there. And based on that, the overall experience can be counted and can be endorsed there. And for the endorsement, you must have to contact the existing ISA Square professional there. So this is the first, or you can directly approach the ISA Square for this endorsement process there. So there you can upload, and definitely it is the ISA Square who is going to verify everything there. But if it is ISA Square professional who is doing the endorsement for you, it is their responsibility to verify every stuffs and then provide the information to ISA Square for their stuffs there. So remember, passing the CCSP examination is actually the first step, and after that we need to get endorsed. So overall, getting the certification for CCSP is two-step process. First, pass your examination, and second, prove your experience there. So minimum 5 year of experience we have to actually prove there. Over and all, you can get some waive off as well there. So this is the another stuffs which we need to understood about this particular certification there. So that is the same thing has been discussed here, and these are the stuffs. Yeah, one thing, length of the examination is going to be 3 hours, a total of 125 question. Out of 1000 points, you must be securing the 700 points to pass the examination there. And the question format is going to be MCQ, but there are some mix and match questions can be also there, which is might be there's some laws given there, and you need to select the country as specific to that particular law there. So this is one specific question sometime coming in the examination there. And the same thing we had already discussed, that these are some of the steps we have for the CCSP syllabus. So let's begin. Cloud concept, architecture, and design. That is what we will be starting today there. So before I'm going to begin, definitely first thing we need to understand what exactly in this particular chapter we will be discussing about that. So cloud concept, architectural design is let you know about what are the different basic building blocks we have there for the cloud. So when I'm going to build the cloud there, what exactly we require there? What are the different concepts related to the cloud there? Like we have multiple different roles and responsibilities there. So who is responsible for what? And how exactly that one is going to be impacted on the cloud there. So you are going to introduce to cloud computing concept there. You will be introduced with some of the roles and responsibility, and definitely some reference architecture, which is going to help me design the overall solution within an environment itself there. So let's begin there. So first thing, what exactly the cloud is. Remember, for the past few years, this particular term cloud has been heard almost everywhere, specifically, when we are then in the organization, when we are working onto the platform there, this cloud is actually everywhere, I can say there. Like if I'm using my mobile phone, and there also I'm regularly prompting out for the cloud storage there. Okay, when I'm working on my desktop, definitely the same thing everywhere. The advertisement, I'm actually checking it out there. Sometimes the Google Cloud, sometimes the AWS Cloud. But what exactly this cloud is? As a security consultant, as a security professional, you should be having a proper awareness of the basic terms there, which is actually very required there. Because when we are going to interact with the clients, when we are going to interact with the consumer, we have to actually utilize some standard terms which is going to help them to implement the solutions as well, definitely. But first thing, you must know there, like when I'm interacting with the consumer, what are the basic things which they have, which I have to communicate with them for this particular cloud. There's some various definitions given there from the various different standardization bodies there. So if I'm talking about the cloud, there could be a possibility that some providers are coming to you there, but they are not the cloud provider. They're just a simple managed service provider there. So how can you differentiate between the CSP and the MSPs there? So these are some of the stuffs firstly we are going to understand there. So I can simply say in a simple word there, cloud is all about accessing the services over the internet there. Any kind of services which you're trying to utilize. And remember, cloud is actually specifically is focusing on the service model there. So we have different stuffs which we require within the cloud, within our data center there. I'm not only talking about the cloud right now. Take an example, I required any of the computations to be done there. What I will be doing, simply I will be purchasing that component, and then after definitely I'm going to do the stuffs on top of that particular component there. But the thing is, if I needed to utilize the similar thing over the internet, definitely if I'm having the computation speed there on my local system, that is good enough to do that any of the activity. But what about if I don't have the computation speed there? Do I need to wait for that particular device to be provisioned and then only I will be doing my stuffs? Or might be I'm having some service which is going to help me provision the services or these stuffs which is not available right now in my infrastructure with some few clicks there. And very many in just in matter of time there, we can actually utilize and simply implement the solutions properly in the environment itself there. So cloud is actually providing you that much of liberty there. Cloud is basically offering you all the different solutions which is going to help you to implement the things on remote computers there. So when I'm talking about the cloud, so cloud is nothing but we have a data center which is available definitely on some remote location there. And now this data center is having full of different stuffs there. We have the stuffs like the compute. We have the stuffs which is related to storage. We have the stuffs which is related to network. We have the stuffs which is related to security and so many different components there. So now what exactly I'm doing here, as a consumer, you are accessing these services over the internet on your local system, and then you are doing the configuration in a way so it is going to provide you the benefit. Remember, cloud is basically an operational model there. And this time in this particular operational model, we are trying to do the activity which is going to help me to understand overall, the implementation part. And based on that, I will be implementing the control and definitely the solutions as well there. For a very simple example, we can take, suppose I wanted to create a workload. Now, when I'm saying workload, it means I actually require a VM, might be, or might be I require a serverless platform, or might be I require a container on etc. There are very many different solutions available there for running the workload there or for running your application there. So if I needed to run an application, first thing I require a proper workload environment there. That workload environment is going to offer me the different amount of processors and the memory here, which is going to help me run my work application on top of that. So with the help of these components, which is the compute, storage, network, and security, I will be fetching these services locally via the browser or might be some of the thin client application there, doing the necessary stuff which is going to help me to configure this application, and with few clicks only I can publish the services over the internet there. So I must say that in this particular service model, main agenda is actually to do the configuration over the internet so I can provide the services as per the requirement. It is the goal of the organization which is enforcing you to utilize this cloud there. There are very many different flexibility we have in the cloud there. So based on this discussion, I can simply say here that cloud is a model which is going to help me do the computation over the internet to fulfill the task, whatever we have. So with the help of internet, I'm just going to, send some instruction. Those instructions received by the provider and entertained by the controllers of the respective service, which is the compute, storage, or network, and they are going to do the task which is instructed by the consumer itself there. So if you are instructing that I need to store the data, so definitely we require a storage controller which is going to receive your request and will do the task. So cloud computing is a model where we are doing the computation, where we are doing the storage, or where we are transferring the data with the help of internet there. Instead of utilizing our local system, this time I'm going to utilize the remote system. This is what in the cloud we are doing. And I must say there, it's a it's a simple definition. It's not any technical words. I'm actually utilizing it here. So it is all about doing the processing over the internet. That's it. Where in the internet, that one is actually depends on the service provider, because each of the provider is having different reasons. I must say there, each of the provider is having multiple different geographical location there. And in each of the geographical location, they have multiple availability zones there. Availability zone is actually going to keep the data centers, and that data center is actually the point, or you can say the location, where my processing will be done there. Which data center you will be selecting is totally depends on the reason there. So even we are also not sure about like in which location I'm actually committing the data, and definitely it is required for the security as well there. Because suppose I'm aware about that my competitors are utilizing the East US location. So I must be going to the East US location, finding the data center of the AWS, and that's it. Try to disrupt that activity there. Might be I will try to make it stop there by doing some different kind of stuffs, or any kind of attacks as well there. So this is to actually improve the security. They will be making sure that this information is completely secret and hidden there. So it is all about this compute there. So cloud, where we are doing the computation, where the computation is going to perform on a third party infrastructure, and the outcome is going to available to you there. So the only thing you're utilizing in the cloud is the resources from the different provider, and that providers are going to help you to access the relevant resources which is required for you there. Now, what is your requirement? Definitely it is based on the goal. So you must be aware about what is the goal. Based on that, what are the strategic activities selected by your organization, and around that, what are the what are the controls we required, which is going to help me to secure the issues as well there. But before that, you must be defining the functions which is going to help you to achieve the strategic goal. And for those functions to implement properly, what are the different resources you require from the cloud itself? Remember, each of the providers are actually offering you n number of solutions there. So it is on your activity, it is on your functional requirement will be actually decide what computations or the what component you require right now for the cloud there. So suppose I'm just trying to run an application on the cloud there. There might be possibility that a simple virtual machine is enough for me. Or might be I wanted to decrease the overall cost, because the cost which is associated with a VM is higher for me. So I want an infrastructure, I want a platform on which I just run the application, and only for that application I have to pay them. So even that one too is going to reduce the overall money there. So we have different stuffs there, like we have the operational requirement, we have the cost related constraints there, and definitely we might also have the resources. People is also one of the resource we have there. So suppose we don't have the quality manpower, and in that case, and in this particular case there, we have to look for the solution which the provider is offering me, so I can minimize even that particular gap as well there for my organization. So cloud is actually having very many different stuffs for each of the user. Now, when you go to the AWS console or Azure console, you will be able to see that lots of different services available there. Like one is actually falls under the compute, another is falls under the robotics, customer enablement, storage, satellite, blockchain, quantum technology, machine learning, AR and VR, application integration. So these are the different category of services which the AWS is offering us there. And each of the service itself is having so many different components there to make your life very much easier there. Similar thing if I'm going for the Azure Dashboard, and if I'm going to check the all services panel, the same thing has been organized here as well. Like under the compute, they're having very many of different services there. And you can just go down and you can look for all of the services which is falls under the compute there. Similar thing for the network, storage, web, container, analytics capability, blockchain there. So you must say there that what we are doing today for each of them, there are some specific service available there onto the cloud platform. This is the reason you first need to understand what are the different steps right now you require. It means what is exactly your overall operational activity you need to be done there. And based on that, you will be selecting the proper function. And around that, you will be designing the security control there. So as a security professional, you should be aware about what are the different functions or what are the different applications which is being utilized by your organization. And around that, you can filter some of the security solutions available there. Definitely, I cannot select the antivirus, okay, for my software as a service environment there, because lower level control I will be not getting in the software as a service there. When I'm saying lower level control, it means I'm talking about the VM related stuffs there, where I'm having access over the VM. I can go install and do the scanning over and all there. It is the provider responsibility in software as a service. So that time we require different tool like contracts, we require SLAs, we require third party assessment report, just to ensure that my stuffs are secured there. So that time different tool is actually going to help you understand the security posture of the organization there. Okay, so till now what we had discussed, that cloud is basically a service model. Previously we were actually purchasing the product and we are utilizing that product there, right? But this time, do I need to purchase the product, anything there? Really not there. This time we just need to purchase the service, and that service is going to help me configure and manage according to the requirement of the organization. So when I'm saying going there for the cloud is basically a service model there. And this service model is going to do the activity for me over the internet there. So based on this discussion, there was very many definitions has been created there, but definitely one of the definition which is highly standard and which is highly recognized in the industry is actually from NIST there. So National Institute of Standard and Technology has given a definition for the cloud there. And according to them, cloud is a computing model. Okay, so I must say that cloud computing is basically a model. And what kind of model it is? It's a service model. Remember this time. So cloud computing is a model which is enabling us for providing a ubiquitous environment. So the environment which can be accessed from any of the location there. It's very much convenient, and definitely it is on demand. So whenever I require, that service is actually available to my desk there. And definitely I can manage and configure as per my requirement. So the first line within the NIST definition is discussing some of the attributes of the cloud there. So cloud computing is a model for enabling ubiquitous, convenient, on demand. That is the three component. Apart from that, the same definition, they had discussed one of the very important stuffs which are there into the cloud, and that is called the shared pool of configurable computing resource. So if I'm going for the second line, in that line they had given that we can access all of this particular feature through network, and for that we are going to utilize the shared pool of configurable computing resource, and those are network, server, storage, application, and other services there. So what do you mean by this shared pool of configurable computing resource there? So when I'm saying shared pool of configurable computing resource, it means we see, if I, as a provider, if I'm trying to offer services to my consumer with the help of single system, it is not it's not actually going to be easier for me to offer the services there, or you can say almost it is not impossible there. The reason I'm saying that even only a single consumer can access all of your resources which are there in a single compute unit there. And this time in a public cloud environment, you're not only offering services to a certain consumer. Your target is actually the multiple different consumer there. And in that case, definitely each of the consumer is having their own requirement there. Like might be some consumer is going to utilize the 64 gig of RAM, and some consumer is might be looking for more than 500 gig of RAM there for the compute unit there. So only a single consumer can utilize all of your resources there. So definitely we need to check it out, all of this particular component there, and then we have to form a huge pool. As a provider, I have to create a huge pool which seems to be unlimited for the consumer. So if the consumer is looking for any of the resources from the provider, they must be, able to utilize any kind of resource at any time there. Definitely it is a contract. It is the overall agreement which is created and designed. Based on that also it will decide it that whether you can utilize that much of resource or not there. But provider responsibility is to make sure that they can merge multiple compute units there, and they are going to create a pool of that particular units, or you can say those particular component, and that one is going to expose to the internet itself there. And definitely the consumer will be checking this particular huge pool instead of going and connecting with the relevant system there. So the cloud computing provider is actually going to create a shared pool of configurable computing resource which can be rapidly provisioned and released with minimum management effort without any interaction with your provider. And that is what exactly the cloud definition has been given there. So all in all, I must say for this particular pool to create, there are some efforts the provider have to put it on here. What exactly those efforts are going to be? So in case of effort, I must say there, suppose I'm having this particular system and I wanted to create a virtual pool there. I wanted to create a pool which is having nearly unlimited resource there. Now for this, what I have to do first, I have to abstract this hardware into virtual format there. And for that, we are going to utilize some of the virtualization tool there. So on top of this particular hardware, you will be running some sort of virtualization tool there. Like one of the simple example for that we can take is the hypervisor. So we have the physical hardware, and not on top of that we are going to install some hypervisor. So hypervisor is basically a tool which is going to help you implement the virtualization concept. So the main goal of hypervisor is to abstract the hardware into the virtual format. So this is actually providing me the abstraction concept here. I'm having the physical hardware, and the hypervisor is actually going to help me abstract this physical hardware into the virtual format there. So I'm having the same hardware there, but this time in a virtual format there only. So this hypervisor is actually going to help me do the abstraction. Abstraction of what? Abstraction of your running hardware or your hardware into the virtual format there. And once it is there in a virtual format there, it will be easier for me to aggregate the solutions there. And definitely for that, I'm going to make sure some kind of automation I can also put it there. But the main goal of this hypervisor is just to put your hardware in a virtual format. And because it is in a virtual format, there is a possibility that I can merge multiple different virtual resources together. And that virtual resources, I'm going to make it available in my pool. And this pool is basically the collection of resources from the different hardware itself there. Now suppose I'm going to expose this particular pool to the consumer. So definitely when the consumer will be coming here, they will be checking this particular huge pool, and they can consume what they require. And when they are done with the task, they will be simply reverting that particular source back to the pool there. So in this way, I will be using only the service which I required, and based on that, I'm going to pay it out there. Now, this is actually what making this particular cloud infrastructure so much flexible and so much cost effective as well there, because this time you're not going to utilize any of the services for the full lifetime there, because the best I can say the concept of this particular cloud is actually the pay as you go model. What you're utilizing, you need to pay for that only there. So you're going to claim the resources, you are going to utilize them, and then you are going to pay for them there. And that is what this particular cloud is actually going to offer you there. But it won't be possible if I don't have this particular hypervisor there. So I must say thanks to this hypervisor or thanks to the virtualization concept, which is making this particular things possible there for me. So hypervisor main role is to virtualize it, make it available to the pool, but on top of that, we will be running some automation. So if I check the difference between virtualization and cloud, so virtualization is going to offer you the abstraction. So I must say hypervisor is actually going to offer you the concept of abstraction. But on top of that, for the cloud, we must have the automation also well there, because this time on the cloud, I'm having consumers from the different regions, from the different location. So I cannot let them control my hardwares there. So they will be actually doing the instruction, sending the instruction over the API, so they can send that same instruction to the relevant controller, and that controller is going to do the activity for them there. Okay, so they should be receiving the request, and then based on that, automatically that resource is going to be provisioned. Let's take an example. If I'm trying to form a virtual network onto the cloud, what I have to do, I have to just click, I have to do few clicks only there. I have to provide some specific value to that resource, and that's it. We are ready to go there. That is what the beautiful feature of this particular cloud is. And thanks to this automation, which is actually making my life easier there. So abstraction is making sure that you are having the virtual pool available there. And over the virtual pool, now it's actually to get the instruction set. And that one is going to offer through the concept of automation there. And once it is done, now finally my resource is ready, and that is ready to publish into the public environment itself there. So the difference between virtualization and cloud is this particular automation. So virtualization only going to offer you the abstraction, but there is no any automation. But in case of cloud, we have this particular automation concept as well there. So that is what the main difference between them there. And definitely this is also going to be one of the examination question there. If you will be lucky there, you must be getting such this easier question as well there. Although we cannot expect a very easy question in the examination there. It should be based on some scenario. Even if they're going to ask you about the automation abstraction, there should be a hidden scenario placed behind that particular one. And based on that, they will be getting the question there. Okay, so that is what. Now, when I'm talking about this abstraction, so as I told, that abstraction concept is offered by whom? Hypervisor. And overall concept for this hypervisor to implement is basically because of this virtualization. So how can we implement this hypervisor, and what are the different type of hypervisors available there? So I must say we are having two type of hypervisors available there. One is called as bare metal hypervisor, bare metal hypervisor, and the another is called as the hosted hypervisor. Hosted hypervisor, which is also known as, so type 1 is also, sorry, bare metal is also known as type 1, and hosted is also known as type 2 there. Now, although it has been not discussed in the CCSP authorized documentation, but yes, we have one more category as well, and that is called as the para virtualization there. Okay, but that one has been not discussed anywhere into the CCSP documentation, so we don't need to actually work around that particular area. But but yes, we should be understanding the concepts of this particular hypervisor. So when I'm saying bare metal hypervisor, and with a very simple implementation we have. So we have this hardware. Take an example, you have a compute unit, you have your machine there, and on top of that particular machine, you are going to install the hypervisor. So this is my hypervisor. Now this example we can take like VMware ESXi. Okay, or might be you will be implementing the Gen server there. So these are some of the examples of this particular hypervisor. And after installing this hypervisor, definitely what are you getting it here? You will be getting a virtual layer, and that virtual layer is going to help you to create the virtual machine there. Okay, so suppose I wanted to deploy any of the virtual resource, now I can do it there. Now what hypervisor you're utilizing based on that virtual resource deployment is also possible there. But yeah, let's suppose that we are utilizing the ESXi. It is going to help me to create the VM, and definitely on top of that VM, now I'm going to install the OS, and on top of the OS, I'm going to install the necessary application which is required there. So if you see carefully, I'm having a operating system for my VM. Now this operating system will send that instruction to the hypervisor directly, okay, to the hypervisor directly. And definitely after getting the instruction set from the operating system onto this hypervisor, this one is going to send directly to the hardware. So the execution is going to be faster here. So if you see here carefully, my OS is directly communicating with the hypervisor, and this hypervisor will entertain that particular request, and definitely it is going to send towards the hardware to do the task there. Because we are having such direct interaction there, so execution is going to be faster and much more smoother there. Plus hypervisor security wise also, type 1 hypervisor is going to be good there, because normally type 1 hypervisor is not having any graphical console, and it is running only the limited service which is required to run there. Like take an example, I just needed to deploy the resources, only those services are actually configured there, and there are some services available there, so I can connect with the remote console there, and I can do the necessary configuration either via CLI or might be via the GUI there. So the main feature here for this particular bare metal hypervisor is it directly connected with your hardware. So execution time is going to be much more faster as compared to the type 2 there. Because in type 2, what will happen there? Suppose you are having this particular hardware. On top of that hardware, first you will be having an operating system, like might be Windows 10, Linux-based OS, or any of your favorite OS there. On top of that particular OS, now you are going to install the hypervisor. Now this hypervisor will send instruction to this OS, and then only it will be committed to the hardware, or you can say installation by the hardware to do the task. But on top of that hypervisor, what you're doing, you're going to create a VM, and that VM is having the OS there. So now this OS is going to send their instruction first to the hypervisor, and then hypervisor will send the instruction to this OS, and then only the execution can be possible. Remember, the difference between this hypervisor and this OS is what the lower level access, how exactly the lower level access has been provided there. Like here in case of type 2, we are always dependent on this OS. So suppose there is a vulnerability here on this OS, will be inherited on top of this OS as well, or you can say on your guest VM. So the virtual machine.
I have a question.
Yeah, please.
So in this type 2, yeah, in the type 2 hypervisor, the model which you've drawn here, you so on top of the hardware is an OS, and then hypervisor VM, and then the OS again. So when you're saying OS, is that like the same OS, or
Yeah,
what is it?
yeah, it could be same OS as well, because there is no any restriction. Take an example in this on
Yeah,
top
yeah.
of the hardware, the
Example.
OS you are having is Windows 10.
Okay.
Okay, and Windows 10 is having one more one hypervisor available there, that is called as Hyper-V. So suppose I can have example, because Windows 10 is having the inbuilt hypervisor available there, that is called Windows
Right.
10. So after installing the Windows 10, you can install the Hyper-V, and after that you can create the VM, and on top of that again you can install the Windows 10 only there. Now it is totally depends what exactly your requirement is, whether you are looking for a Windows 10 or might be a Linux based operating system. It is totally on you there. It's not like
Okay.
the hypervisor which we have, I cannot install on top of that, because after getting the abstraction, you can install anything there which you can install on a traditional hardware there.
Okay, so can you explain what is the need of this kind of model? Like, why is it this way? Why is there an OS, and then, why are there two OS?
Okay, great. So before I'm going to provide the response, does anyone who is trying to give this response, means there is a question asked here, if anyone wanted to explain here why exactly we require this structure, means why should I go
Well,
OS on top of the OS?
well, this type 2 hypervisor is, at least in my experience, something that say that you have an existing machine or laptop or whatever, and you want to on that laptop run something else separate that is isolated from your laptop itself. By taking your laptop already has Windows 10 on it already, and now you want to run another application completely separated, like it has its own C drive, it has its own D drive, it has its own network interface, and you don't want to install that on your laptop could be for many reasons. It could be that you want another operating system. At that moment, you take a type 2 hypervisor and you can run that inside your laptop. Whereas with so it's something that you can do at home. You can do it kind of quick and dirty, and you can use it for maybe somewhat production environments. But I would say the type 1 hypervisor is for when you want to, in a production server farm, you want to run a whole bunch of machines that are kind of all on the same level, and it's going to be more the initial learning curve to get a Hype 1 hypervisor. You're going to have to learn new things, whereas a Type 2 hypervisor, you can just do it if you just know Windows 10. You don't really have to learn anything. You can run something. I don't know if that's a good answer, but
Yeah, definitely. It's actually a good answer. But let me just explain and add some more on top of that particular one. What he explained that is actually the operational steps which we are normally utilizing with this particular hypervisors there. It means when you are actually having this hypervisor now, so let's suppose this is my hypervisor. So I'm sort of hoping that this infrastructure is already there. I'm having only this hypervisor available there. On top of this hypervisor, one of the benefit I'm getting it here that I can now create multiple isolated box, or you can say isolated or sandbox environment there. So take an example on your base hardware, you're having a good amount of resources. Might be you have 4 CPU processors and you have 32 gig of RAM there. Okay. So what you can do, like take an example, how much RAM we require to run the Windows 10 there? Might be even 1 GB is enough to run there, but there's some minimum requirement of each of the operating system is there. But definitely if I wanted to run the OS, okay, even the 1 gig is also enough to run the operating system. But how smoothly it is running, it is totally how much processor and the RAM is allocated to that system there. So the one of the benefit I'm getting onto the on top of the hypervisor, that I can create a multiple isolated and segregated operating system environment there. So suppose I wanted to do the server consolidation, or you can say service consolidation there. That is what the benefit I will be getting because of the hypervisor. I can create multiple isolated systems, and each of the systems cannot communicate with each other until and unless I'm creating a channel for them to communicate with each other. But do we have such liberty previously on independent hardware? No, not really. See, previously we can install multiple OS onto the same hardware, but we can boot only one operating system at a time. So suppose you wanted to run multiple services, you have to boot one operating system, you have to install all of the services on top of that, and then only you can publish it. But suppose I require isolated systems there where one service cannot communicate with another service, or suppose if one of the service is compromised, another service should be safe there. Such environment I cannot provide, because if my OS, if my system is compromised, it is very much possibility that other services which is running on my system is also going to be there, very easily compromised. But this is not the case with this hypervised environment there. We can create multiple isolated boxes, you can say the virtual machines, and on top of that we can install the different OS there. It could be Windows, it could be Linux, it could be Android based as well there. So again, it is totally depends on what OS you are selecting there. And on each of the OS you are running different service. Might be on one system you are running mail server, on another system you are running Active Directory server, on another service system you are running FTP server, on another system you're running different services there. In this way, on the same hardware you're running all the services, but all of these services cannot communicate with each other. So there are two benefits. First, now I can utilize my resources efficiently. So previously when you are running one service, like suppose mail server, you're running mail server, and might be that mail server is being utilized or might be not. In case if it is not being utilized, it means your hardwares are sitting idle. they're not utilized there. So I can say that I'm paying for the resource, but I will be not getting the return on inputs, right? This is one of the concern area we have. Another benefit. So the benefit I must say there onto the hypervisor, that we can actually run multiple services. So even one of the services not being utilized, I'm having other services which is being utilized there, because now this time I'm running multiple services onto the same hardware. So it is providing somehow the efficiency there. And definitely because of this, now you can slash your IT expenses. So if I'm utilizing this virtualized environment, definitely the overall expenses is going to be reduced there. Instead of purchasing the 5 different hardware for the 5 different services, you will be purchasing only one hardware, and you can run like you are running 5 different hardware there on top of that, which is completely isolated. Second thing, reduce downtime, and it is going to enhance the overall resiliency as well. With virtualization, the another benefit we are getting, that if due to any reason, if one of the virtual machine is down, take an example, this particular virtual machine is down there. So what will happen there? Are we done? It means, do I require lots of time to recover it? So I must say no. With virtualization, one of the benefit we are getting, that we need to just save the configurations files which is available for this particular VM. So the moment I require, I can actually fire up immediately there. The only thing you require the proper backup of this particular virtual machine, or might be the snapshot of the virtual machine there. So remember, snapshot is basically the point in time backup of your virtual machine there. So everything, even the running memory, also you can take the backup there. And because of that, services efficiency is going to be greatly enhanced there. So the overall downtime you can actually reduce there. And because of that, the overall productivity is going to be increased there. So coming to your question, why, if I'm running this particular, virtual boxes, so one of the benefit we are getting is the efficiency. Definitely, downtime can be reduced there, and the another thing is totally siloed. They are totally isolated. So I'm not actually having now concern that if one of the box is compromised, if the another one is also going to be. So I hope you are getting,
Thank you
your
so much.
answer.
That was very clear. Thank you for such a detailed explanation. One last question. So
Yeah.
this, okay, so in type 2 again, there is one hardware on top of which all of the others reside. So now if that hardware is like, we give resources like a couple of GBs and couple of CPU, that works for both the OSs, right?
Uh, can you come again?
She's
So for the
asking.
hardware, the underlying hardware, if
Mhm.
we provide some resources, right, some CPUs and some memory,
Plan.
that
Mhm.
would apply to both the OS, right?
Which both of those? You're
Yeah,
talking about
yeah,
the guest and
yes.
the base was both, right?
Yeah, yeah, yeah.
See, yes, it is actually going to apply to both of them there. But the thing is, if I'm increasing this hardware memory,
Huh.
it will be definitely reflected to your base operating system there first, correct?
Correct.
But
Okay.
whether you require this particular hardware on your guest VM or not, that is totally your call.
Okay. Okay.
So suppose you wanted to utilize the same hardware
Mm.
on this particular guest VM. So yes,
Mm.
you can go there and you can increase that particular resource now. So suppose previously I was utilizing only 1 gig of RAM for this
Mm.
particular VM. Now I
Mm.
can increase. Why? Because now it is available. So if you have the hardware capability, definitely you can increase the
Okay.
software
Okay.
RAM as well.
Perfect. All right. So it depends on the. Yeah. Sure.
Yeah.
Thank you.
More well.
Just one thing that so the answer you gave and the explanation you gave was of an hypervisor and not comparison between type 1 and type.
Yes, definitely. I'm not comparing right now with the type 1 and type 2, because this is actually the overall feature of each of the hypervisor. It's not like only the type 2 or type 1 is actually going to. If I'm going to increase the hardware, definitely it will be reflected to the guest VMs there, and you can easily utilize there as well there. So it's not related to type 1 or type 2 there, correct? So yeah, these are the different benefits we have here. So as I told that, in case of type 2, we are always dependent on the some of the operating system. So let's take an example, like you are on the base operating system, you're utilizing Windows 7. So on top of that, even if you are building a very secure OS there, like suppose you are utilizing server 2019 there, which is one of the secure operating system, or might be some Linux operating system, which is not having any vulnerability. But because the base operating system is having vulnerability, your guest VMs are actually going to be in a problem there. Because if someone is having control over the hypervisor, I'm talking about this particular hypervisor. If someone is having control over this particular hypervisor, they can easily control all of the guest VM you're actually building on top of that there. Okay, so definitely we need to provide proper security, not only to the base operating system, but also to the hypervisor. So instead of managing 2 layers of security, which I can actually reduce it to 1 in case of type 1 here, so why should I go for such kind of vulnerable area there? So normally type 2, we are utilizing for the testing purpose there. You will rarely seeing that we are utilizing type 2 hypervisor in a data center, because definitely if any of the vulnerability there, see there are 2 things. First thing, it is consuming extra memory. Do I require this particular OS there? Because I can install hypervisor directly on top of the hardware. So do I really require this particular operating system there, which is going to consume just the extra amount of memory only there, or the RAM itself there? And the second thing, it is also going to increase the attack surface there. So any of the vulnerability on this OS is actually going to inherit on your guest VMs as well. So why don't we go and install only the tool which is enough to run my services, and I will be concentrating on that only tool to secure it enough there, right? So we are making sure that we are providing proper security to this type 1 hypervisor with all of the tools available there, and then will make sure that my base infrastructure is actually safe enough. Remember, this hypervisor security is the responsibility of the cloud provider in case of cloud there. And definitely in the cloud also we require this hypervisor, because without virtualization, there is no cloud. Now this is also one of the examination term actually right now I'm indicating towards. Without virtualization, there is no any cloud. So if there is any question you are getting in the examination, which is actually talking about and asking about some of the virtualization dependencies there, so make sure that virtualization is actually the core element of your whole cloud computing. Because if I'm not having the virtual component, I cannot actually share it over the internet there. Is it possible to share your hard disk drive over the internet to me there? It's tough, right? Because now we can actually virtualize it. I can actually make a copy there. So it is possible that you can share it to me there, and I can directly access your hard drive, and I can utilize there for the storage blocks to be stored up there. But previously, it is not the stuff which we can actually perform there. So again, this hypervisor is actually making our life very much easier for us there. So you should know the difference between this type 1 and type 2 hypervisor. And remember, this difference is because of this kernel, which is available with this particular ESXi there. So I must say this ESXi, which is one of the hypervisor, is having their own kernel. And because of that, I can directly interact with the hardware. But when you go to the type 2 hypervisor is not having their own kernel. It's just an simple application. And like other application, it also required the interaction of the OS. So operating system can offer you their kernel, so you can do the execution with the help of hardware. It means hypervisor is always, type 2 hypervisor is always dependent on the base operating system. The reason is hypervisor, they don't have their own kernel there, so they cannot interact with the hardware directly. This is the reason sometime for the faster execution, type 2 hypervisor require a small modification on the operating system side, so they can directly interact with hypervisor for the faster execution. Okay, and this is what the third category available we have, that is called as the para virtualization. So in case of para virtualization, we are modifying the operating system and definitely the hypervisor itself, so they can directly communicate with the hardware itself there. So in this way, I don't require I don't require the dependencies over the OS. Definitely the kernel is going to offer by them only, but this time, I will be directly communicating with kernel to make our work easier with the hardware itself there, which itself is going to make it, somehow faster as compared to type 2 there. Definitely it is not as fast as type 1, but at least we are making some speed enhancement here if I'm comparing with type 2 there. So when you are going to,
Can you repeat this para virtualization once more? How is it how are you making it more efficient than type 2? What is the changes which are being made?
so we have this hypervisor right now, which we are utilizing. This hypervisor is dependent on this particular operating system there, which is actually offering you the kernel. So what exactly happening there? We having this particular hardware. So what exactly is happening there? Right now, this hypervisor is giving a call to OS, and operating system call is going to interact with the kernel, and then only it will interact with the hardware. Now here, for this para virtualization support, this operating system will be getting modified there. So we will be actually modifying the code within operating system. So this base operating system itself needs to be modified along with the hypervisor itself there. So the hypervisor can make call directly to their kernel. So instead of going through the operating system call, I will be directly making call with this your kernel, and we can interact with the hardware itself there, which is making sure that this hypervisor can make direct call to this kernel and definitely to the hardware after that, which is going to increase the security and efficiency as well.
Thank you. Thank you very much.
So over and all, I can say there it will increase the efficiency, but not as fast as compared to the type 1 there. So most of the hypervisor which is available at the provider site is actually at the type 1 level. But in some cases, if you're looking for this para virtualized concepts there, so you will be getting this option as well there. So definitely when you are going to look at some of the images available onto the provider side, they will be also offering you some para virtualized image as well, which is definitely going to help you to fire up the machines based on this particular specific requirement there. Now, the moment we are going to move into some labs there, just to understand the concept, I will give you a small demonstration on top of that one. But yes, remember from the examination perspective, you should be only knowing the difference between the type 1 and type 2 there. Para virtualize is actually not being the part of the examination there. Okay, so you can actually also eliminate this particular part. But yes, just for the information, you should be keeping it with you there.
And just you said something about security. Even type 1 hypervisors have in the past had some much less security issues, but there still have been some type 1 security issues. So
yeah, definitely. If and it's a correct one, a correct statement here. So I must say there, like, see, any of the operating system which you're utilizing, it's not only about the type 1 hypervisor, but any of the base operating system you're utilizing to interact with the hardware is having some security issues always there. See, I must say there, nothing is totally safe in the world there. Even if you're saying that I'm having a very secure system there, which is going to make sure that everything is communicating properly and interacting with a very isolated environment there, there is a loophole available there. So might be right now it is not revealed, but in the future, when the moment when you are going to interact with their services, we are going to able to check it out there. Type 1 hypervisor is not an exception there as well. So when you go on the internet, and there is a website I must say you to visit, that is called CVE details, common vulnerability and exposure details there. So when you go on Google and search for the CVE details there, and on that website, you just search for any of the hypervisor, like suppose ESXi only there, or might be Gen server, or might be Hyper-V. You will be able to see there are multiple vulnerabilities available there. But what exactly the provider is making sure that they should detect these vulnerabilities proactively, so they can reduce the possibility of attack. actively there. And if they are not able to do such things there, definitely the risk is on you as well. It means as a consumer, you also at risk. This is the reason we must be looking for the provider's process, how they are actually tackling up the security. Most of the providers, I'm not only talking about the cloud providers, even for the managed service providers also, they are utilizing some sort of risk management framework, RMF. And this risk management framework, specific guideline, you can actually read it out in 837. So NIST in their special publication, 837 has discussed about this risk management framework. And according to this risk management framework, one of the statement given there that you need to continuously verify the effectiveness of your control there. It's not like today my firewall is providing me the all kind of security there. It doesn't mean that tomorrow it is also going to offer me the same level of security. Definitely tomorrow there is some new vulnerabilities, and based on that you have to actually tackle up the issues there. So whatever you feel that it is safe today might be tomorrow it is not, because actively there are some groups available on the internet or all over the world which is looking for some vulnerability there, which is related to might be the confidentiality or might be integrity or might be availability impact is going to be there. Main goal of those group of users is to find the vulnerability and exploit the vulnerability there, and after that they can actually go inside and steal the data, and definitely they give more and more damage to you there. So what this risk management framework is saying that you have to continuously re-verify. Remember, this is actually the result of the 9/11 attack there. After 9/11 attack in US, that this FISMA Act, Federal Information Security Management Act, has been created there, and which has given rise to this particular NIST. And NIST has also one subsidiary there that is called the FISMA there. Sorry, I'm saying FISMA, FIPS there actually, Federal Information Processing Standard, specifically for the cryptographic stuffs there. So there, you can say there is a chain actually has been created. So yes, even for the type 1 hypervisor also, we have lots of vulnerability available there. But what we have to check that current hypervisor must not have the vulnerability. And if it is having, then it should have to be, filled it out with some kind of control there. So we have to check it out, the control options which is available there. So based on that, we can actually implement the solutions properly itself there. Okay, so I think till now we are okay here. So from this cloud concept, architectural and design section, the main thing is to discuss about the building blocks developed to cloud-based system, and perspective of consumer. Mainly we have to check it out there, because when we are moving on to the cloud, consumer is having more and more concern there. How exactly my services are going to be tackled? What are the processes their provider is following? What compliance standard they are having? How exactly they are implementing? How exactly they are hiding their staff members? What are the physical security aspect of the provider? There are so many different questions, specifically if you are having very sensitive data to be getting processed onto the cloud. Let's take an example. I'm actually working for a military organization there, and I'm trying to utilize the cloud computing. Before I'm going to utilize it there, I'm having so many questions in my mind there. Is it safe to keep my data onto the cloud? What about if this particular data is leaked? What is the implication on the whole country? These questions, when I'm actually going to filter it out there onto the cloud, might be cloud is actually one of the most you know it's a kind of service which is giving me more and more threat there. Well, the reason is cloud is a shared model, first thing. And the second thing, it's actually multi-tenant environment there. And when I'm saying multi-tenant environment, is multiple different consumers around the world, which I'm not aware about who they are and from where they are coming from. So if I'm suppose working in such environment, take an example, nowadays we are very much utilizing the shared workspace there, and you are working on your desk, you are using some sensitive data, and for a 5 minute you out from your desk there. So how much safe that particular data is? Okay, so it is something like that we have in the multi-tenant environment only there. So how exactly we can actually rely on that particular provider there, and what exactly the provider is doing for that? this is what some of the questions we have in our mind there. So after completing this particular chapter, we will be okay to answer all of these particular question there. It means I should be okay to select one of the provider after this particular chapter, because we are going to have various points to prove whether the provider is actually offering me the secure services or not, and for that what they are actually doing there. And then definitely we will be also discussing some securities and principles of the cloud. So cloud computing, as I told, that it's an operational model and a set of technology which is actually going to help me to implement the solutions properly there. There's so many technologies we have. As I just discussed, hypervisor is one of them, but is it the hypervisor only? Not really. We have the automation related controls there. We have security related stuffs there. So when I'm going to attach everything there, we have n number of computing resources and the security services we have, which is making this particular cloud actually a secure environment there. Remember, cloud is having potential to enhance the collaborations there. Now cloud, because thanks to cloud there, take an example of GitHub. If you are a programmer, GitHub is one of the very interesting platform for you there, where exactly you can work, you can collaborate with your team, which is located in another location, and you all can work on a single project there, no matter where you are there. So again, this is actually increasing the collaborations there around the work, what we are doing right now. It is also enhancing the agility, or it is actually providing you the agile environment there, the scaling capability, and definitely the proper availability. This is what some of the capability we are getting into the cloud computing environment there. And plus, very much it is providing the opportunities to reduce the cost, and thanks to the pay-as-you-go model of this particular concept is making my life very much easier there. So simpler way of describing the cloud, as I told, that cloud is actually offering you a huge pool of computing resources there. So simpler way of defining the cloud is actually a set of resource like processor, memory, or even the storage as well there. So you are going to put all of these resources together, creating a huge pool, and now I'm letting the consumers to utilize that particular pool. So consumer will be utilizing the resources what they require. When they're done with the task, they will simply revert. And because they are paying only for the amount of resource they're utilizing, so definitely it is a win-win situation for the consumers. And definitely even the provider resources are all also being utilized every time, because the moment when you submit back to my pool, it is being utilized by another consumer there. So in this case, provider resources are also being utilized 24/7, and plus consumer is also paying for the resource what they're utilizing. It means provider is also earning, and definitely consumer is also able to preserve their overall cost there. So this is what exactly the cloud is doing for us there. And again, thanks to this virtualization concept and the abstraction concept, which is actually making my life easier, because for any kind of deployment, I don't have to contact to my provider there. I don't need to interact with them there. Like previously with MSPs, every time anything I have to deploy there, I have to connect with them. I have to tell them requirement, and based on that, they are actually going to start doing the provisioning for me there. Again, in cloud, this is not the case. Just you will be getting the management console, and that one is enough for deploying the resource there.
Can I add one concept, I think, to follow up on Madhura's question? That
Sure.
is that when you have this hypervisor, and whether it's a type 2 or a type 1, and you put several of those machines in there, right? Say that you have your physical machine has 16 gigabytes of memory. You can actually then have 5 virtual machines that each have, say, 10 gigabytes of memory. And you would say, how is that possible when you only have 16 in total? How can you have 5 times 10 gigabytes? What the hypervisor then does is it will time slice it and make 10 gigabytes available to one, then to the next, then to the next, then to the next, then to the next, and then back to the first one. So that's also when an important part that we need to realize also in our in our day-to-day world. That is that when we install a server, we install a lot of servers on hypervisors Rajiv. And when
Yep.
we install a server on a hypervisor in a cloud or on our data foundry, that in reality, the server may have, say, 32 gigabytes of RAM, and we've installed 10 servers that each consume 24 gigabytes of RAM. So what the hypervisor will do is just allocate small chunks of time slots for each of them to rotate through it. Why am I mentioning that? Is because it's an important issue to understand when you think about performance in that context. Available, how much is really available of that physical processor.
Correct. So it's a big good point to be added by here. So I can see here, yes, it is the amount of resource which you have in your physical environment, that one only you can consume there. And previously this concept which the Bart has explained there, it's actually the time-based division, what we are doing it there with the processors there. So within the processor we have the capability of multitasking there. So multiple tasks can be executed at the same time there. And again, thanks to the multitasking capability, where each of the process is actually going to be allocated with a certain amount of time there. So when I'm done with the task, I can actually jump to the another one, and each of the task is actually getting a specific amount of time as well there. Again, it is actually the hardware dependencies which is actually going to work here. Okay, so remember, we are always dependent on the hardware there. If I'm not having that much of hardware, like an example, I'm trying to form a 64 gig of system there, and my application is going to actively utilize the 64 gig of RAM there. But in my physical system, I have only 32 gig of RAM. Although I can form the virtual machine for the 64 gig of RAM there, but I'm not able to power it up. I'm not able to consume that much of the reason is I'm not having that much of resource in my hardware there. Okay, so we are dependent on the hardware only. But yes, the benefit what we are getting with because of the virtualization, that we can aggregate resources together. So if it is not possible to fire up the system with 64 gig of RAM because of the hardware limitation, so definitely I can add some another system in a pool, and I can create such a huge pool environment there. So even if the commodity hardwares are also going to help me to fire and create a good amount of virtual environment, and definitely a secure virtualization platform as well there. So definitely when we are going to discuss further there, it is going to let us clear all the concepts as well there. So what we had discussed till now is what is cloud. So if you're going to check one of the documentation which is given there by the NIST, remember this whole CCSP syllabus is more aligned with the NIST perspective there. So when you check the NIST perspective over the cloud, specifically one of the documentation which is given there by them, NIST in their NIST special publication 800 and 145. So NIST in their special publication 800 and 145 has given the definitions of the cloud, and the documentation name is NIST definition of cloud computing, which is giving you proper clarity over the official definition there, which has been accepted by most of the organizations around the world. And as we had discussed already, that particular definition, like cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resource that can be rapidly provisioned and released with minimum management effort or service provider interaction. And I hope this time the full definition is clear to you all there, because we had discussed all of the component of this particular definition there. So based on that, I must say there that this definition should have to be clear to you all. And remember, this is one of the accepted definition by most of the industries right now around the world there. But along with this NIST, there is one more definition given there by the ISO. So if you're going to take the ISO documentation 17788, so according to them, cloud is a paradigm for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration on demand there. Now, see, virtual resources I can understand here in the definition, but what is this physical resource? Do we have any options to share the physical resource as well? So yes, so see what exactly they're trying to say here in the definition. In the cloud, when you're going to utilize the cloud computing resource, there are two options we have there. One, Either I can utilize the shared infrastructure. And when I'm saying shared infrastructure, it means the computing resource which you're utilizing, it's already being shared with another consumer. Okay. But if I require a dedicated infrastructure, might be a dedicated host machine, which is being accessed by me over the internet because of the compliance reason there, because I cannot host my data on a shared environment there, provided is also offering you that option there. But definitely for that, they're charging you more because this time you are dedicating a specific hardware for yourself there. So definitely the charges are going to be higher there. But yes, due to compliance reason, most of the organization is having this requirement as well, that they are looking, they must be running their workload on a dedicated hardware, on an isolated system. So even that one too is possible to offer you to the consumer. So we can actually share this whole physical hardware to them. Definitely that one is virtualized and then only it is shared. It's not like I'm going to share the raw physical hardware over the internet. It is virtualized and then shared. But yes, that complete hardware is only for you there. So apart from you, no one else is utilizing there. And definitely you can create your own isolated network there, which is making sure that access to the services which is configured onto that hardware is really tough for everyone, not only for the other consumers, but also even the provider as well. Because remember, provider is also one of the concern for us as a consumer, because provider may be able to access your data, specifically if the data is not encrypted. And because of that, data leakage possibility is always there. So these are the two definitions which is given there by the NIST and the ISO there. And one is for that, the reference documentation is 800-145, and the another difference documentation is ISO IC 17788. Now remember, for the examination purpose, if you're trying to go for that, these numbers, you need to remember it there. So this number 800-145 is the NIST definition for the cloud computing, and the same thing from the ISO side is 17788 as well there. There are some additional guidelines available there. So if I'm looking for some reference architecture for the cloud, like roles and responsibilities and other stuffs here, that one has been discussed under the 500 and 292 documentation in the NIST there. So we are going to check it out the same there, how exactly these stuffs are actually going to work. So till now, any question for me, guys? Do let me know if you have any question till now, what we had discussed.
No, all good so far.
We are good.
Okay. Perfect. Thank you. Okay, so the next topic which we need to understand here, specifically from the cloud perspective, like, see, we have so many different stuffs there, right? And in the cloud specifically, we have so many different terms as well. But from where we should start that particular point to discuss everything there? Like, we need to understand roles and responsibility, which is very much required for the governance purpose there. So, but before I'm going to discuss further on any of the topic, sorry, one of the important steps which we have to understand here, that in the cloud, we have few features given there. So if you are dealing as a consumer, if you're dealing with a cloud provider, you should know whether they are the cloud provider or might be they are just the general managed service providers there. You should be aware about these particular part there. This is the reason NIST special publication 800-145 documentation is also very much relevant for us, because according to them, there is a 543 rule given there, and those 543 rule is actually indicating towards the different aspects of the cloud itself there. So next I'm moving towards this 543 rule of the cloud. So what is that? So we have some essential characters of the cloud. As a consumer, if I'm dealing with the cloud, I must have to verify whether all of these particular features are available there onto the cloud. So these are the essential features of the cloud there. So after connecting with all of the consumers group and some of the well-known organizations, NIST has developed this particular essential characters there. So if I'm going to entertain the cloud, definitely I am looking for those 5 features. But the interesting fact here, that if you're going to take the ISO perspective, International Standard of Organization perspective, according to ISO, there are a total of 6 key features they are looking for within the cloud. But as I told, that widely accepted standard we have for the cloud is actually from the NIST side. This is the reason in most of the documentations, even from the specific providers like Azure, AWS, or Google, you will see there that they are discussing only 5 features there, not the 6th one. But what are those sixth feature is, which is actually not fits into the NIST guideline. So that feature is actually called as the multi-tenancy. Multi-tenancy, we know that cloud by default is multi-tenant in nature, but that is not the feature what the NIST is looking for within the cloud, because normally the essential characters within the cloud, which is given there by the NIST, is moreover their benefits as well. But multi-tenancy moreover a concern according to NIST, specifically for the consumers. So this is the reason this is not the part of this particular list there. So what are those 5 features are? And those 5 features you can actually remember with this small abbreviation there. It's called the BROM, B-R-R-O-M, BROM, where B is basically for broad network access. So what do you mean by this broad network access? And what exactly it is actually offering me? What key benefit here? When I'm saying broad network access, it means the services are available over the network and access through a standard mechanism that promote the use by heterogeneous thin or thick client platform there. So whether you're accessing the cloud services from your mobile phone, from your tablets, from your laptops, definitely from your workstations there, each of the platform is actually available for you. And thanks to the internet capabilities today, it is making it more and more feasible there. Nowadays, we are not having those slow, creepy, 2 kbps of download speed there, right? Today, I can get the speed up to 100 Mbps in my home only there. And because of this capability, I must say that cloud is very, very much feasible for all of the consumers nowadays there. Mostly internet is available in all of the locations there. I'm not taking some of the examples, might be in some location, it is still not. But yes, more in most of the locations where exactly the business is feasible there, okay, we have this internet connection active there. And because of that, the services which I'm trying to access is now available in all of the location. And the cloud platform itself is designed in a way so you can access the cloud platform even from your small handsets as well. Although it is not recommended that you should be configuring the services from those handsets, because might be you're not able to see if some specific characters or some specific options there clearly because of the lower screen resolution and other things. So the misconfiguration chances are going to be higher. So best practices is not recommending you to go for the configuration over the mobile phones, but yes, at least you can do the monitoring there. Like in case of Azure, if you're going to utilize Azure mobile application, that one is giving you all the liberty to monitor the virtual machine and even the configuration as well there. So we have broad network access feature, which is where we are actually accessing the cloud services from the standard mechanisms there. So with the help of your browser, no matter which browser you're utilizing, you can access the cloud services. And it's very easy to provision any of the services there. Just a few clicks required. Yeah, definitely we require the proper understanding of the service there so I can provision it properly. But if I am aware about the product, configuration is so smooth and so easy there. So this is the concept of the broad network access there. Another feature we have, so I must say, check this now, the R, which we can say the rapid elasticity. See, this whole definition is not in a certain order, so you can actually remember in any order, just to make sure that you can remember this word and based on that 5 features, because it is again very much relevant for the examination there. Because they will be actually defining the attribute in the question, and then they might ask you what exactly this feature is called about. So you should be aware about this particular definition there. So when I'm saying rapid elasticity, It means the capability which is available here, which is where we are provisioning the resources, and for that we don't need to interact with the provider. So rapid elasticity is making sure that we can rapidly provision any of the resource, and for that I don't need to connect with my provider definitely there. Another thing, it is elastic in nature, like a rubber band which can increase or decrease as per your requirement. The same thing is also possible here. So suppose I wanted to increase the computing resource. Let's take a very simple example that your initial requirement is having only one CPU with 1 gig of RAM. And to run your application, this is the sufficient resource you have there. But as the number of users are growing on your application, it is tough for us to manage the application utilizing this small amount of resource there. What we can do, we can fire up the workload in a scalable environment there. When I'm saying a scalable environment, it means I'm making sure the resources is provisioned in a way so the moment it requires more resource, automatically it will provision it. Like there is a feature available we have that is called as the scalability. So when you check the scalability features of any of the provider, let's take an example of Azure. You can also take the example of AWS there. So if I'm going to take the example of AWS, and if I go to the EC2 console here. So EC2 console is basically for the compute. And remember, when I'm saying compute, we are indicating only two resources, processor and RAM. Even in the examination, if you're getting this term, make sure that your focus is only on those two components, not onto the storage, not onto the network. So when I'm going to the EC2 console, which is offering me the compute services, and when I go down, we are getting lots of different features here. And we have one feature that is called the target groups or load balancers, and others. We have the placement group as well. So these are some of the different features available there. And when I'm going to the Azure, we are having one service that name is a scale set. So for this elasticity to understand, we can take an example of this scale set there. So if I'm going to the scale set, okay, you can see here we are having the virtual machine scale sets there. Now, if I'm forming this scale set, there is an option given there that we can define a condition. But before that, I must be defining what is the minimum amount of resource I required to run my workload. So when I'm creating any of the resource here, if you see, it is asking for the skill set name and it is asking for the image which you are wanted to utilize. Remember, whenever you're forming the skill set environment, it means the environment which is flexible enough, you must be utilizing your custom image, the image which is already equipped with your application. So you are going to create a snapshot, or you can say you can create an image which is having all of your necessary services running there. And whenever you're forming the virtual machine, that image is being utilized here. So when I select the image, either I can utilize the public images offered by the provider, or might be I'm going to utilize my private image. Like in my case, marketplace items I have here, but if I click on my items, I don't have anything here. The reason is I had not created any private image within my account yet. But if you have, you can actually able to see it from here. And you can also share that particular image to other consumers or might be to other subscription as well there. Okay. Now, once your image is there, and this image is, remember, is actually your custom services only there, you have to define the size of the virtual machine there. So here, based on your requirement, you will be selecting the size which is required right now. Like suppose might be my initial requirement is going to be okay with 2 CPU with 4 gig of RAM, but this could be not enough as your services are going popularity in the market. So suppose I formed, I actually written a blog, and that blog is so much popular there, and because of that I will be getting so and so much users on my blog there, and because of that definitely I have to increase the resource because of the number of users are getting connected is now might be more than 10,000 or might be more than 20,000 there. So that resources, it means 2 CPU with 4 gig of RAM is not able to cope up with this requirement there. So what we should do now, we can form this system in a scale set environment, because I'm also having a body here that if I'm going to increase the resource, and what about if the number of users after 10 days is decreased? I need to pay for all of the resource, but that resource is not being utilized there. So it is better to form that VM in a skill set environment. So when you go to the scaling section, just to check the skill set rule, here you can actually define the conditions, like how many initial instances you require to run your workload. So if I'm going to define one, it will fire only one virtual machine with 2 CPU and 4 gig of RAM. That's it. But as the number of users are getting connected more, the processor utilization will be more. RAM utilization will be more. And because of that, we can define a custom policy here. And here I can define what is the minimum number of VM required and what is the maximum number of VM required. Might be I require 100 with the same capability. Remember, if I'm going to fire up one more VM, it will be firing up with 2 CPU with 4 gig of RAM only. But for that, there is a scale out and a scale in rule you are going to define there. A scale out rule is what is the CPU uses, so automatically it will add one more VM for me. It means I don't have to manually increase the number of VM. I will be just defining the condition, like if the processor utilization is greater than 65% from the last 5 minutes, then increase the number of VM by 1. So it will keep increasing the resource if the resources are being utilized higher than 65% here. Same thing, if I don't require this resource because the less number of users are connected, so automatically it will decrease the resource. If the CPU threshold is back to normal, like might be 25%, then automatically it will start decreasing the resource by 1 there. Now this is basically the feature which falls under the scalability, or you can say elasticity there. So cloud is very much a scalable environment, and because of that, we can get this elasticity feature where we can provision and deprovision the resource as per the requirement, and it will be very quick. Okay, it doesn't require any procurement process or something. All you just define the condition, and it is going to increase the resource automatically for you there. Definitely, we are trying to decrease the overall loss, and thanks to this particular feature there. So rapid elasticity is going to let you increase the uptime by utilizing these particular rules. And definitely each of the provider is having their own way of defining the rule, but mostly the concept is going to be same what we had seen with Azure there. It means the similar tool or the similar kind of options you will be getting it there only. The only thing is going to change is the API or might be the web console there. So this is the second feature we have, which is actually included with your NIST definition, 800-145. The third feature we are already aware about, and that is called as the resource pooling. Thanks to resource pooling, I can actually increase the resources anytime there. So this elasticity capability we are getting because of this resource pooled environment there. And you know that resource pooling is actually offered by whom? The provider, because we don't have any control over their physical resource. Physical resources are actually going to manage by the provider only. So I have to check how exactly the providers are offering me service, whether they are offering me service through a pooled environment or it's just the single capability which is offered by them to me there. And in that case, definitely if I require more resources, it will be tough for them to mount it and definitely to provide you the elasticity feature there. And because of that, the overall availability is going to be suffered there. The fourth feature we have is the on-demand self-service. As I told earlier only that in cloud, we are very much relying on the automation. And because of that, consumer don't have to interact with the provider to provision any of the new service. So suppose I wanted to deploy virtual network, I don't have to interact with my provider. All I will go there, I will do few clicks and that's it, I'm done. Now I'm having an isolated network there. And definitely any of the security products, if you are also trying to configure, like suppose I'm trying to create a DDoS plan there, distributed denial of service plan, or might be I'm trying to configure the IAM policy, or might be I'm trying to form the virtual machine, might be I'm trying to form load balancer. Just few clicks you need to do, and the service is ready, definitely it is the best practice which is going to help you understand what is the best possible way of configuring and managing the services for the internet there. So that one, at least you have to take care of that. But yes, on-demand self-service is making sure that consumers can unilaterally provision the resource without any interaction with the provider itself there. Okay, and whenever they require, they can actually configure and manage it as per the requirement itself. And then final feature from the NIST is called as the measured service. Remember, if I'm using the term measured service for this standard definition, this is the same definition we have to actually utilize even for the if it is going to be asked in the examination over there. So remember, cloud systems are automatically being provisioned there and optimized based on the consumer need there. So cloud system automatically control and optimize the resource by leveraging the metering capability. It means here there is always the option we have where we can measure how much the CPU is being utilized, how much the RAM being utilized, and accordingly we actually going to pay it out there. So the moment we start utilizing the resource, the metering capability is making sure that they can measure the overall utilization, because some resources you are going to pay on per minute basis and some resources you are going to pay on per hour basis there. And some resources we are paying on per user basis. Remember, per user is actually for software as a service. So if you are purchasing the Office 365 license, it is actually based on number of users, not based on the number of system or the processors there. But if you are working in infrastructure service, the payment you are going to do based on the per minute basis as well. Let's take an example of compute. If I'm using the processor and the RAM, it is going to charge you based on the per minute basis there. So they are going to check how many minutes you have utilized the VM, and around that the costings are actually going to be defined. So I must say there, in case of IaaS, we are paying only for the resource what I'm utilizing it there. So initial cost for the infrastructure as a service is pretty much down. But if I'm going to utilize infrastructure service for the long run, it is very much costly solution. A very simple example, suppose you are using a VM from the last 1 year, and because they are charging you for per minute, so now you need to add up all them, and now you can check like how much you're actually paying there. Like estimated cost with 2 CPU with 4 gig of RAM in my recent activity has shown that it is 2022, which is almost I think it is 25 to $30 there. Okay, so in this case we are paying $22 for in a month, and now you need to add up for a year as well the same way there. Definitely, if I'm in an enterprise, my workload is not going to be static every time. It means might be I'm going to increase the number of VM, or might be it will be decreased there. So you are going to pay what you're consuming there, nothing more than that. That is what the main feature there. And because of that, the consumers are going to get only the going to pay only the operational expenses, not the other stuffs there. So that is the 5 features we have from the NIST there. And as I told, there is one more feature we have that is called the multi-tenancy, but that is not from the ISO perspective. So I'm not going to discuss that particular component right now here, because it is unnecessarily going to create a confusion right now here. So according to NIST 800-145, we have these 5 features. And again, if you're interested in getting the certification as well, so make sure that you are aware about each of the component precisely there. It is also going to help you in the industry there, because when you're interacting with any of the consumers or might be with your client there, you have to let them know what are the features what the providers are offering you there. So these features you can also count there. And on top of that, cloud specific capabilities are also there, which you can actually discuss with them to let them understand that. So these are the 5 features we have. And apart from that, we have the 4 deployment model. And when I'm seeing for the deployment model, we have public cloud, which is going to utilize by anyone. We have private cloud for a closed group of users. We have a hybrid cloud, which is actually the mix of public and private. and we have the community cloud there. Although community cloud you will be not able to see in most of the definitions given there by the vendors, but according to NIST, even the community is actually the part of the deployment model there. So we have 4 deployment model, which is public, private, hybrid, and community. And then we have the 3 service model, which is IaaS, PaaS, and SaaS, infra, platform, and software, and AAS is as a service. Remember, apart from this deployment model and service model, there is one more model we have, but this model is not specifically discussed in the NIST documentation. But because we are working for the security and we are going to understand the security aspects, so we must know even that model as well. But that model has been given there by the CSA, Cloud Security Alliance. So that is called as the Cloud Security Alliance logical model. And according to that, we have metastructure, we have before that infrastructure. So infrastructure, metastructure, then we have the application structure, and then we have the infrastructure. So when we will be starting our next discussion, definitely in our next session there, then the agenda for the next session is going to be the same. We will be comparing the deployment model, service model, and a logical model, and we will see the connection between the security, okay, and these particular models there. This is going to help me design the architect properly there, because we have some well-known architects options available there. So if I understand all of this model, it will be helping me to design the cloud properly.
Sorry, can you repeat those CSA logical model?
Logical model. Yeah, it's infrastructure. We have meta structure. We have application structure, which is also known as appli structure. And then we have infrastructure. So that is the 4 logical models given there by the Cloud Security Alliance. So I think
So
we
this
are
is
good.
also part of sorry. This is also part of domain 1, and it falls under design, right?
Okay, so now try to understand this way there. The book which we will be utilizing is actually a reference book for the CCSP. Okay, but if you feel that with after reading all the content, it is enough to pass the examination, actually there's just not, I can say there, because there's some information which we have to take it from the NIST and from the Cloud Security Alliance documentations as well, which is going to help us to prepare for the examination as well. So this is the reason which I had added. So it is not the part of the first chapter there, Cloud Security Enhanced Logical Model, but it's very relevant for the examination there.
Okay. Good to know.
Okay. So I think we are good to go here. For the first day, I think it is enough. So I think we are good, guys.
Yeah, we are.
Yeah. Thanks, Rajiv. Appreciate it.
Thank you.
Thank you. Thank you, everyone.
Thank you.
See you on Monday. Yep.
Yeah, thank you very much. Take care.